Hi, my name is Lucas Weintraub, and this is a video on how to factor. So what is factoring? Factoring is breaking down a product into its factors. Now, to understand this definition, you have to understand what products and factors are. A product is simply just a number. It's an expression that's been simplified down to its simplest form. Now 15 is as simple as it can be, whereas factors are numbers that multiply together to make that product. You might recall this from multiplication, and it's basically the same thing, but just the opposite operation. So multiplying asks the question, what number do these numbers multiply to? Factoring, on the other hand, asks what numbers multiply to this number. If I were doing multiplication, these arrows would be flipped and pointing towards 15, as 5 times 3 equal 15, but we're doing factoring, so we're breaking it down. It's also important to note that factors leave no remainder. It's not like I chose 5.7 times like 3.1 and that was equal to 15. It's important to keep these whole numbers and integers, and that proves to be really useful in lots of problems, and I'll also show you later when you don't have to follow that rule. So what are the factors of 12, for example? 12 can be written as 4 times 3, and these are already factors. But 4 can be broken down even further. 4 is also equal to 2 times 2. Now we already broke down 4, so we're not counting it as a factor. And 3, 2 times 2, these are the factors that make up 12. And you can check that for yourself. You can see that 2 times 2 times 3 equals 12, and that's really obvious if you move back up this little chain, because 2 combine to make 4, and then multiply by 3, they combine to make 12. Now, there are other numbers that are also factors of 12, and that is 1 and 12 itself. That's because 12 divided by 1 equals 12, with no remainder, 0r, not or. Whereas 12 over 12 equals 1, and so no remainder. And this leaves us to an important observation about the difference between numbers like 2 and numbers like 4, which can be broken down and which cannot. So there are prime numbers and there are composite numbers. Prime numbers are numbers with no divisor other than 1 and itself. So the numbers 2 and 3 are prime numbers because no other numbers multiplied together make 2 and 3, except for 1 and 2 or 1 and 3. Now composite numbers are numbers that are made up of factors. 12 and 4 are made up of other numbers, so therefore they are composite. And the composite numbers are the crossed out ones with the line, and the prime numbers I labeled with the circle. 4 is made by 2 times 2, and 12 is made by 4 times 3, so they're obviously composite. And here's a list of the first prime numbers and the first composite numbers. So 2, 3, 5, 7, 11, 17, those are all prime. 4, 6, 8, 9, 10, 12, and 14, those are all composite. Now 1 isn't on either of these lists just because in math it makes a lot of things check out when you don't consider it to be prime or composite, but that's not necessary for you to know. Just treat it as fact that 1 is just 1, and it's not prime or composite. I also want to claim that any finite number has a unique prime factorization. So 2 times 2 times 3 is the only way to make 12 using prime numbers. There's no other like 2 times 5 times 3, because that creates 30, and which is not equal to 15. So now let's do some more examples. So some constants, we did 15 before, but what about a number like 70? So you can recognize that any number ending in 0 is a multiple of 10. And so that multiple of 10 is written as 10 times 7. And those are perfectly good factors. 7 is prime, but 10 can be further broken down into 2 times 5. But leaving it as this is perfectly fine. However, if your teacher asks you to fully factorize it, then 10 times 7 is not the correct answer. What about 3,600? Now this also has some zeros at the end, so this is a multiple of 100 because it has 2 zeros. This can be broken down even further. I'm just gonna blaze through it. 2 is times 18 equals 36, and then 18 is 2 times 9, 9 is 3 times 3, 100 is 10 times 10, and 10 is 2 times 5. And so all of these prime numbers multiply together equal 3,600, because each time we broke it down even further. And just going back up the chain, undoing what we did, we end up back where we started. So let's move on to binomials. So binomials are just a collection of two numbers added or subtracted together. So what about 3x plus 6? That's a binomial. And I'm hoping that you know what variables are. This is just a variable x. And they share a common factor. So we can factor something out, and that factor being 3. Because this is what you get when you factor it out. When you multiply 3 back into this, you do FOIL, so 3x, because that's 3 times x, and then 3 times 2, you end up back right where you started. And that's what's supposed to happen. It's the opposite of multiplying. It's decomposing the numbers that multiply it together. Something a little more complicated, which I'm only briefly going to cover, are quadratics. You might have a quadratic equation like x squared plus 2x plus 1. Now there are tips and tricks for solving equations like these, but I'm just going to show you now that this is actually x plus 1 times x plus 1, or x plus 1 squared. And if you do FOIL, you can check for yourself that this does equal x squared plus 2x plus 1. The same goes for 3x squared plus 4x plus 1. This is equal to 3x plus 1 times x plus 1. And if you FOIL this out, this will equal 3x squared plus 3x plus x plus 1, which gives us right where we started. It's exactly what we started with, which again is what should happen. So I want to move on to factoring out non-factors. I'm just going to give you another polynomial, like 24x cubed plus 8x squared plus 6. But sure, all of these have a factor of 2, but what if I wanted to factor out 7? Can I do that? Well, I can sort of do it, and it's perfectly valid actually. What we want to do is, once you factor out a 7, 7 is going to be a multiple, right? So it's going to be one of the things, so 7 times. And we're going to be left with something inside because we had all these x's. Now, if we're multiplying by 7, to end up back where we started, we have to divide by 7. So 24x cubed over 7 plus 8x squared over 7 plus 6 over 7. So this, when you FOIL it, gives you 24x cubed plus 8x squared plus 6. I should rewrite this because that's not 7x. 7 times, well, hopefully you get the gist of what that's supposed to be. But my point still stands that you can factor out any number from any equation or any expression. You just need to undo what you do to keep the equal sign. So if you factor out maybe another binomial, you'll have to divide by the binomial. And you can learn long division for polynomials later on. But if you're just doing numbers, like maybe 15, if you want to factor out, like let's say 7, again, this is equal to 7 times 15 over 7. The thing is, it's just, these aren't proper factors. 7 is, sure, maybe 7 is a whole number, but 15 over 7 is not. So that's why we don't consider these to be true factors. But we did factor, like the verb. And that's what's most important about this video, is for you to know how to factor. So I'm going to end off this video with a real-world application. So Lucy is putting a new tank in her aquarium. Her provider only sells dimensions of at least 2 meters and at most 10 meters, and also only in whole lengths. So she only sells like 2, 3, 5, 7 meter dimensions of length, width, and height. So Lucy's aquarium is slightly less than 3 meters tall. If the tank holds 105 cubic meters of water, will the tank fit? So we want to know if this box will fit inside her aquarium. And to do this, you have to know the relationship between volume and length, width, and height. So volume is equal to length times width times height. And maybe you learned that in geometry, and this is the perfect time to use our knowledge of factoring, because this looks just like a product and its factors. Now, what's our product? We're given our product. That's what factoring asks. If you remember, factoring asks what numbers multiply to this number. We want to find out what side lengths multiply to 105. Just so you know, there could be multiple answers. There are many ways to multiply and combine numbers and get 105. But I'm going to show you that the only ways to do it will give you a certain answer in this specific problem. So the only factors of 105 are 1, obviously, 3, 5, 7, and 105. So, of course, 105 and 1 are kind of redundant because it's itself and 1 is the factor of everything. But 3, 5, and 7 are important because they're the only solutions that fit within 2 and 10 meters, because 105 is too long or too tall or too wide, and 1 is too short. So 105 is therefore equal to, oops, my phone died. Moving on, so 105 is equal to 3 times 5 times 7. So volume is equal to length times width times height, and the volume is equal to 105. That doesn't necessarily mean that the length is 3 and that the width is 5 and the height is 7. It could be any one of them. The width could be 3 and the length could be 7 and the height could be 5. But no matter what configuration, the tank is always going to be too tall, because we already said that the aquarium is slightly less than 3 meters tall. And so the aquarium, the height of the aquarium, which I'll call H, is less than 3 and less than 5 and less than 7. So no matter how you make it, the tank will not fit. So the answer is no. The tank does not fit in the aquarium. Now that's all I have for today. I hope you enjoyed my video. If you have any comments, critiques about my video and anything that you would like to see in the future, please comment below, and I hope to see you in the next video. Bye bye.